Done? And then share my screen.
Okay.
Okay.
A and 19, B is 1. 3A is on the top, 1 minus e to the power of -2 over 2.
The funny thing is the only person who's listening to this right now, well, maybe Caitlin might, but it'll just be David, and he'll be listening to his own voice, slowly saying answers. Okay.
I still got it wrong, so.
All right, let's talk about discrete and continuous. Let me grab
I think I remember.
my
I
book.
did turn these to decimal.
New stuff. Are you excited for new stuff to actually learn something in this class? Wouldn't that be nice?
I did
And not just review things you already knew?
And then the B is e to the power of 3 minus e over 2.
Okay. So a random variable is discrete when there are a countable number of outcomes.
Number 6 is okay. A is -2 over 5. And B is
These could be like whole number values or half number values. An example of this would be if I said all the shoe sizes that there are. I am sharing, right? Everybody at home?
14, 16.
Okay. You could make a list.
And
So if you can make a list of it, it's
B
good.
is approximately 16.
Continuous is when there's an uncountable amount. For example, if I said, how tall are you? How'd Emily do?
Okay, so
David? How'd Emily do?
she got like
All of them right.
something like that.
Well, that's good. Well, you guys can talk about it. All right, so uncountable amount of outcomes, example, height. For example, if I said list all the heights, well, you could start saying, okay, so like if I said list all the shoe size, you could be like, I don't know, let's start at like, maybe you could be a 5, you could be like a 5.5, you could be like a 6, you could be a 6.5, right? You get what I'm saying? Or if it's height, I could say, well, I'm 5 foot 1 inch, or I'm 5 foot 2 inches, or I'm 5 foot 3 inches, but are these the only heights you could be? No, there's actually like an infinite number of heights that are just between 5'2" and 5'3". Do you see what I mean? Because you could be any fraction of an inch or any decimal place between those two heights. So, but you can't be, they're like, our no size is 6.13, right? You're either a 6 or a 6.5. So do you see the difference between discrete options and continuous options? Okay. So we're going to try example 1 together. We've got to decide if they're discrete or continuous. Okay. Let X represent the number of Fortune 500 companies that lost money in the previous year. Could I make a list of the companies that lost money in the previous year that are in the Fortune 500? Do you guys know what the Fortune 500 are? They're the 500 like biggest companies that make the most money in the United States. Yeah. So that would be discrete. The volume, how much gas is in a 21-gallon tank? Continuous or discrete? It could be 1 gallon, it could be 2 gallons, it could be 3 gallons. Could it be 3.5 gallons? Yeah. Could it be 3.75 gallons? Yeah. Could it be 3.7891115 gallons? Yeah, this is continuous. So my biggest advice here is to think about the space between. Basically, if there's like, if everything is an option in the space between, then you need to, that's definitely continuous. All right, we're going to give prizes for example 2. So you go ahead, try discrete or continuous.
That is absolutely ridiculous.
Have you decided to audition?
Yeah,
Cool. Have you signed up for time?
no.
Okay, make sure you
What?
sign up today. If you go to that email, that gives you like a Schoology website and then has like the link to like everything you need. Awesome. Okay. So hands up if you want to be called on, please. For either of them, you get prizes for this. Krista Mitchell, not into it today.
I'm catching up on the notes. Just got the note sheet.
Okay. Krista's 1, Michaela's 2, 3, Tanner 4. Two and 4. Who's number 2? Michaela?
Okay, so for A, it's discrete or continuous. I am backwards. Continuous. Sorry.
That one's continuous because you could be like, so if you think about it, think about 3 miles per hour and 4 miles per hour, right? That's how fast a rocket could be going. I mean, I hope it's going faster, but it could be going there, but it could also be, there's also infinite options between there. That makes it continuous. All right, Michaela, what do I have left? Where did that? And a stingray and a lobster, right? Okay. Stingray, lobster, yellow bouncy ball.
I'll have a stingray, please.
Okay, I'll have a stingray, please. Thank you. All right, for you.
That's discrete.
It is.
You can count them always, no like half calves or.
Exactly. You could have 1 calf, you could have 2 calves, but between there, there's nothing, right? There's no options between, which is why it's discrete. Nice job. Lobster or bouncy ball? Yes. Sorry, I'm not used to people asking for those anymore.
Maybe that's just a random.
There you go. All right, a discrete probability distribution. It lists
So maybe it's
all possibilities and their probabilities. Oh, and it's a chart. Mitchell, can I scoot this up or are you still copying? Okay. All right. So here are the rules to check and see if it's a real probability distribution. What do all the probabilities add up to?
I think I said +3, not -3.
Anybody know? What do all the probabilities add up to in a probability distribution? If you have all the options, adds up to 1 or 100%. And probabilities
I said 4 over 5.
all have to be between 0 and 1.
Okay, so a problem with those will be negative. And that's going to be -2. Right, -2. I just thought of some doing that. Or that way.
All right, now I forgot to include the data on this one, so I'm gonna just draw a quick little chart here so you can
2 plus cosine
have it.
over 5 plus.
So write this down with me, please.
1 plus 1 over 2 plus.
Little tiny chart, and it's gonna have 6 rows in it.
How? This is like the same problem 3 times.
You okay, David?
Okay. Okay. Now to the approximations. So, what did you do? You get for your approximations?
Okay, so this is the data I was supposed to put on here that I didn't. 1, 2, 3, 4, 5,
8.
24, 33. 42, 30, and 21.
Maybe this was wrong. I looked at like the instrument, but to the left and to the right.
So the problem says an industrial psychologist administered a personality inventory test for passive aggressive traits for 150 employees. So these must add up to 150. Let's check really quick.
What did you do?
Yep. Yeah, so those add up to 150. And it says that 1 means that you're extremely passive and 5 means you're extremely aggressive, and a score of 3 means neither. What do you guys think you are? Would you think you'd be extremely passive, aggressive, a little bit passive, a little bit aggressive, or neither?
Oh, so the
A little bit aggressive or lots of aggressive? Okay, so Megan places herself probably in that 5 category, extremely aggressive. How about you, Tanner? You don't talk enough? Okay, I think that might be passive, is what that might be. Yeah, Michaela, Crystal, Mitchell, what do you think you guys are?
Probably like a 4.
A 4, little aggressive? Krista, Mitchell?
What are the ratings out of?
Out of 5. So like a 1 is extremely passive, 3 is neither, and 5 is extremely aggressive. So like, for example, let's say that you're in a math class or you're in a whatever class and somebody makes a mistake. Do you just shut up and go along with it? If you shut up and go along with it, you're probably passive. If you want to be like, I'm going to say something, then you're aggressive. If you're even willing to correct the teacher and they messed up, it means you're probably very aggressive, which is good. I like that. Especially when it comes to mistakes. Of course, I'm not a big fan of it when it comes to fights. Mitchell, Krista, what do you think?
Let's go with passive.
You're passive? Krista?
Also passive.
Yeah, you're passive. Okay. So anybody have an idea of how we can figure out the probability in this column? If we know 24 people were in this column, how can we figure out what probability that is?
24 divided by 150.
Good. So each one we're going to take that amount divided by 150. So go ahead and do that in your calculator. Look up and see if you're right when you're done. Dang it, Sandy. I can't stop. It's all chicken wings and hot dogs and bologna in my head.
They said our whole 16. So it's pretty safe to assume that it's been ultimately 16. But it's also, because it's getting much closer.
Did I do something wrong?
Wow, okay.
Okay, so what should these add up to if we did it right? Right. These should add up to 1, which they do. Okay, that is a probability distribution.
It did say meters.
You don't even need to have like the frequency part in there. You just need to have the values and the probabilities next to them. And then if we were going to graph it using a histogram is a fancy word for what? Come on, Megan.
Bar chart.
There it is, bar chart, a bar chart. So if we were going to quickly graph these, we would just say, I don't know, here's like 10%, here's like 20%, there's 30%.
I misplaced what sign, like what? 3 times?
Not a good day, huh?
No, not a good day, I guess.
Let's see, getting a 1 is like a 16%.
I think I did get the.
2 is a 22%. 3 goes up to 28. 4 is a solid 20%. 5 is 14. So it looks to me like most people are neutral, but then people tend to fall on the passive side a little bit more than the aggressive side, at least at this place. All right, to find the mean of a discrete random variable, you essentially take, you add up all of the x's times their probabilities.
No, we did it normal, right? I think we did it normal.
Are we okay with me moving on to the next page, everybody? Okay. All right, so here we go. We're gonna try it out ourselves. We're gonna use the exact same data. So I'm just gonna write this in. We got X is 1, 2, 3, 4, 5. We had our, let's see, 1, 2, 3, 4. We had our frequency, which was,
Okay. I mean, do you know the slope?
was that like 24?
24, 30, 42.
So then your normal would have been 1/2, right?
Thank you. And then all of our probabilities that we did, which was 0.16, 0.22, 0.28, 0.20, and 0.14. Remember, those added up to 1, which is what we wanted. Okay, so to find the mean, the first thing we have to do is, actually, I probably should have another column on here, my bad. I wasn't thinking about having the frequency, so you just have to add that in. Okay, so I said that the mean was if you take the x times the probability, right, and add them all up. So let's do that right now. So in your calculator, you're going to do 1 times 0.16 is 0.16, and then 2 times 0.22 is 0.44, et cetera.
I mean, clearly just put, one in into the slope field.
Now, before I add them all up, look at me really quick. What's a reasonable answer for this? For the mean of these numbers? Is 0 reasonable? No, because 0 is not, it's somewhere between 1 and 5, right? For an average. Okay, so if you get something like 8, you're definitely wrong. Or 1,000,000, you're wrong. You guys get 2.94? So the mean is, we're going to call it 2.9. By the way, I wrote down all the instructions on how to find variance and standard deviation down here. So these are steps 1. This is step 2. Now we have to find the individual deviations, which is x minus mu. And then we're going to square all those deviations. And then we're going to take the probability times all those deviations.
We have a positive 4 and a negative 4, right?
And remember, which one is your x? Which column? the first one. So we're going to take 1 minus 2.9 for this first one. And then 2 minus 2.9, 3 minus 2.9. How we doing, people at home? Following along? This should be very similar to like stuff we've done in the past, right?
Wait, but isn't there like a 2x squared, or do you take the x out? Yeah, because when you distribute, or not distribute, when you FOIL x plus h, you're gonna be left with an x squared. And there's already an x squared on the other side of the equation.
By the way, in your homework, there's only one of these.
Oh, I just go.
For the last column, you're going to take the probability times this x minus mu. So at that first one, it's 0.16 times 3.61.
Oh, I thought we were trying to find a general function. Yeah. Because in a general function, we have no idea what x is. What's the other one?
Did you guys get the same thing I did for these? Okay, now let's see. I'm going to write these off. This was number 3. This is step 4. This is step 5.
Well, yeah, that's what we did. right?
Step
That's what we were-
6 is to add them all together. Now, normally we would, for a variance, divide by how many we had, right?
So it's simplified equation.
But we're not going to do that because this is a probability distribution. They all add up to 1. So if you divide by 1, you'd get 1.
And then we just get the answer rather than,
And then how do we go from a variance to standard deviation?
Well, thing, unsquare it.
Square root, yep. Unsquare it. You're right. You guys getting about the same thing I do? Okay. Okay. Last thing we're talking about is an expected value. How are we doing? Can I move on? We need some more time. Krista, you need a little more time? Okay. All right, expected value. Last thing we're doing. So an expected value is essentially the mean of a probability distribution. But this is used with real life a lot, used to make decisions. For example, everybody who runs the lottery does this. So we're going to make a quick probability distribution. Here we go. I'm just gonna make this one sideways because I don't have a lot of room.
Oh, hold up. I don't think that function down there is for getting the flood.
Okay, so the first question is, how much could you win? What's a possibility for how much you could win?
500.
$500, but you spent $2 to get there, right? So we're gonna call that $498 because you could win $498. Remember, you spent $2 to get there. How about another one?
240.
Mm-hmm.
Because if you put a one in the bottom function, you get 3.
Then we got 148, right?
Mhm.
And 73. Everybody understand what's going on?
A whole either.
But what's the most common thing that happens to you if you play a raffle?
You don't win.
You lose. So what would your
-2.
-2? So the goal here is that the raffle is going to be overall negative, because otherwise, why are they having a raffle if they're giving away more money than they're taking in, right? All right, probability. So it says that there's 1,500 tickets sold and that there are 4 prizes, right? So the chances of you winning this $498 is 1 in 1,500. Same thing with all of these, except for the last one. What are your chances of winning -$2?
The rest.
1,496 out of 1,500. All right, so now we're gonna have to multiply these out. We're gonna get some decimals. I know that this looks nasty, but here's how you're gonna do it. On your calculator, you're gonna put in parentheses, 1 divided by 1,500. And then multiply that by 498, but make sure that 1 in 1,500 is in parentheses. I got 0.332. You guys get the same thing?
Mhm.
So do the same thing to the rest. Remember, if you just hit second enter, it'll put back exactly what you had before. And you can just change that one number. Okay, then we're gonna do a summation where you add all these together. You guys get the same thing as me? -$1.35. And that means it's a good raffle. It means on average, somebody's going to lose the raffle, which is what you want, right? If you're running the raffle, otherwise, why are you having a raffle? Like, if you just want to give away money, then just give away money. Don't make people lose money. But in general, you're going to make money on this. So if it's negative, you're good. And if it's positive, you're bad. All right, one more. And so you get to try this one. I am going to turn off my camera for this one. And then you can check your work in a minute once I finish it. 2, 3, 4, 5, 6. Can somebody tell me why I'm calling this 6 things instead of just 5 things? There's only 5 prizes.
There's a negative chance.
Right, there's a chance that you totally failed at it, which is likely. Definitely going to give a prize for this one. All right, I'm going to stop sharing. You guys all know the layout. And stop my camera. I'm not going to stop my camera. No. Watch, look how creative I am. Ready? No, it's just the ceiling. I suppose I could still be sharing my camera if I wanted to. Anybody not know what's happening right now online? You guys all good? Okay, everybody should be trying this on your own. Or better yet, I could do this, which will give you some light, and then just, keep it over here to myself.
So where are you at? You're on example 6, right? What's the farthest that you've got? So I tried making a function and I tried just putting it in, but I nearly have the exact same thing as if I just use a function behind there. And I still haven't given them bottom. Actually, just with the book size. Give them a little long. Did I do that one? I don't think I did.
go ahead and raise your hand if you wanna throw yourself in the ring for the final prize. Give you a second to finish up. Okay, help me remember who did what.
So Michaela has a marble ball and stinger. Marble ball and stinger. I do.
Oh, Michaela's got a bunch of stuff. Okay, that, Krista, baseball
No,
shark.
no, I'm gonna have a baseball. Kristen just have a shark.
Mitchell has the orange red one. And that's Emily. All right, actually gonna have to open up that for you. Yeah, sure. That's that. Is it broken? Yes,
Yeah, so.
so broken.
sometimes it's hard to, you know,
I have any more bags? I'll have to bring one from home. All right, Michaela's up for it. Krista, Mitchell, Tanner. No. All right, Michaela, you're 1, Krista's 2, Megan's 3.
And that cancels out with, another 8, which is your office, no, another, so it's next to about
1.
8.
Okay, it's -$3.08.
That's right. -$3.08. Correct, ma'am. Here's all my work. All right, I'm gonna stop the video now. So pause if you want to, David or Caitlin.